Welcome to our next commercial solar training lesson. The goal of this lesson is to take a deeper dive into some of the things that we discussed in the first module. So we're going to cover things like key solar system components. We'll review some key solar terminology. We'd like to go over some popular customer questions that you most likely will be asked. And we'd also like to give you a listing of some helpful websites that you can use for your reference. In our very first lesson, we reviewed how solar works once the sun hits the solar array, so feel free to revisit that lesson if you need a refresher. I would like to now move into what each specific component of the PV solar system is and what it means. A PV solar system typically consists of 5 basic components. First, we start with the solar panel, which is sometimes referred to as a solar module. It is composed of multiple solar cells that are electrically connected to increase the total power input. The panels are then encapsulated in a tempered glass for weather protection and for ease of handling. Now, a solar array is simply a group of solar panels that are wired together. Next, we have racking, or is sometimes referred to as mounting for a solar system, and it's essentially the structural part of the solar system that's responsible for attaching the solar panels to either the roof or the ground. And I'd like to show you quickly what these look like. So here is an example of what a racking option would look like for a flat roof mounted solar system. This here is an example of a ground mount racking option, and this was installed at a commercial facility. There are different types of racking options, which will completely depend on the design, the aesthetics, and the budget of the customer. So we're going to dive deeper into that in a future module. So the energy that's produced from the solar panel is then transmitted to what's called the inverter. This is our third key solar system component. And this is what converts the energy into the AC energy that's required for all grid-connected solar systems. Essentially, there's a couple different types of inverters. You've got a central inverter, and there's also string inverters. They operate very similarly. And then you also have microinverters. So I'd like to show you the difference between the two. Central inverters are connected to groupings of solar panel arrays that are wired together. They're typically floor or ground mounted, and they range in power from anywhere from 50 kW to 1 megawatt, and they can be designed for either indoor or outdoor use. Now, you may also hear the term string inverters, which operate similarly to a central inverter, and those are typically installed on a wall or some other vertical structure. So this is what a central inverter would look like. This particular inverter was installed for a 200 kW ground mount solar project in Tennessee. There's also microinverters, which can be installed on each solar module individually. So you can see in my diagram here, this is one individual panel, and you've got the microinverter, which will attach to the back of the panel, and each individual panel will have one microinverter. So essentially, if there are 300 panels for your customer's system, there's going to be 300 microinverters. These are fairly new to the marketplace, and they're typically considered when there are any type of shading issues. The cost for microinverters is typically higher, but they provide certain advantages, specifically for maybe smaller or more complex solar systems. Some of these advantages are maybe if there's a failure, it would mean that only one panel would be affected versus an entire string of panels. But the majority of commercial and industrial projects that we have built use either string or central inverters. The inverter technology definitely continues to evolve, so we'll be sure to keep you updated on the latest technologies that become available. This is an example of a project with microinverters. This particular customer specifically stated that they wanted microinverters. So you can see them here on the back of each panel. These little black boxes, that's the microinverter, and you can see them here on every single panel. So the inverter is connected to the electric meter, which is simply a device that measures the amount of electric energy consumed by the business. You will want to ask your clients if they know whether or not they have a smart meter on their building. Smart meters record consumption of electric energy in intervals of an hour or less. This data is communicated back to the utility for monitoring and billing, and it can allow our team to provide a much more detailed design and a much more detailed working model for your client. If your customer has a smart meter, then they most likely have access to their interval data, which they can then provide to you along with their 12 months of utility bills. So once a system is producing energy, your client might want to see how much energy they're producing. So rather than constantly going to check the meter, most inverters provide a system monitoring tool that can be installed. So this allows not only for energy production monitoring, but it can also act as a potential troubleshooting tool. If there are any problems that arise, you will be able to see what's going on through the system monitoring. So to recap, essentially there are 5 main components to a solar PV system. You've got the panels, the racking, the inverters, you will need the meter, of course, and system monitoring. Now that we've covered the key components of a solar system, I think it's important to review just a few key solar terms. The first one I want to go over is kWh, it's the abbreviation for kilowatt hours, which is a unit of energy. Just to give you an example, kind of a visualization of what this looks like, 1 kilowatt hour represents a 1,000-watt load operated over a period of 1 hour, which is the equivalent of essentially the usage of a plasma TV. Just to kind of give you an example of what that means. I mentioned grid connected in the last video, and just so you're aware, a grid-connected solar electric system generates its own electricity and feeds that excess power into the utility grid for later use. The PV system that your customer installs must be connected to the grid in order to be eligible for any types of incentives or rebates available in your area, if there are any. In PV solar, the balance of system refers to things like wiring, circuit breakers, surge protectors, essentially everything other than the key solar system components that we just reviewed on the previous slide. So now that I've gone over some of the terminology, I would like to move into some of our more popular customer questions in our next video.